Hey guys, so we have 14.5 difference of squares. Okay, so before I give you the formula for difference of squares, I just wanted to kind of think back to when we were foiling, okay, and kind of do the difference of squares backwards just to see why this happens. So consider this first one I have expand. Notice that both of these factors are almost identical. The only thing that's different is one of them has a plus sign and the other one has a minus sign. Okay, so we want to see what happens when the factors are identical, just with the plus and minus sign difference. So we would FOIL these. So you would multiply the first terms and get 9x squared. You would multiply the outside terms and get negative 12x. You would multiply the inside terms and get positive 12x. And then you would multiply the last terms and get negative 16. Now, you should notice these middle terms. You have negative 12x and positive 12x. So those just go away to 0. So we're left with 9x squared minus 16. Okay, so when the factors are the same, but with that positive and negative, what that does is that makes those middle terms go to 0 or cancel each other. Okay, and you're just left with the first term squared and the second term squared with a minus sign, right? Because if that minus sign wasn't there, then the middle terms wouldn't cancel out. Okay, so now I took this same problem and I said, well, let's factor it. Okay, now we were factoring quadratics, but they always had that middle term. So if we thought about this before I give you the formula for it, if we thought about this from all we know right now, basically this has the middle term of 0, right? Okay, if we can always put, plus 0, plus, 0 doesn't change anything. So if I wanted that middle term there, I could just make it 0x. So now what this is saying is I need factors of 16 that are going to, factors of negative 16 that are going to add to give me 0. Okay, well, the factors of negative 16 that are going to add to give me 0 are positive 4 and negative 4. Okay, now this one is actually a little bit different. I should have chose something that doesn't have 9 here in front, but it doesn't really matter for us right now. But so you see how that changes that. That'll make it 0 on the inside. So that means that my terms I would need are 4. I need one to be positive and one to be negative. Now, like I said, this is a little bit different because there's a 9 here. So we would also need to take that into account. So we would need to think of factors of 9. So that in this case it would be 3x and 3x. Now let me actually show you what that would look like if we did not have the 9 there. That was a bad choice. So let me see. Let's just erase that. Okay, so let's say that the 9 wasn't there. Okay, then again, you would have factors of negative 16 that give you 0 in the middle. So x plus 4 and x minus 4. Okay, but like I said, that 9 does change things. We'll also have to take the square root of that. Okay, just like we took the square root of 16 to get 4 and 4. That's the quickest way to do it because we know that both factors have to be the same, right? We said that over here. Both factors have to be the same in order for this to happen where the middle terms go away. So essentially what you're doing is you're finding the square root. Because up here, when we did 3 times 3, wasn't that just 3 squared? And when you did 4 times 4, that's just 4 squared. So when you're going to do it over here, you're just finding, well, what's the square root of 9x squared? What's the square root of 16? And putting a minus sign. Okay, so the formula is exactly that. When you have a squared minus b squared. So for example, you must have perfect squares. What are the perfect squares? The perfect squares are 1, 4, 9, 16, 25, 36, right? You could keep going and going and going. 1 squared, 2 squared, 3 squared, 4 squared. Okay, those are your perfect squares. If it helps you to list those down on a piece of paper, you can write out 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 5 squared equals 25, okay, and keep going. That might help you with some of these problems, because I think what's going to happen is sometimes you're actually going to divide by 2 instead of taking the square root, things like that. So if that helps you to give yourself a little cheat sheet, that's fine. All right. So the formula says, when you have a perfect square minus another perfect square, all you do is you take the square root of a and you take the square root of b, and then you have a plus sign with one and a minus sign with the other. Again, making one plus and one minus is what cancels out that middle term, so that you only have 2 terms instead of 3. All right, let's try it with a couple examples. So the first one says factor b squared minus 1. Using our formula, it says a squared minus b squared equals a plus b times the quantity a minus b. So first you need to check, is this a difference of square problems? Is this a perfect square, and is this a perfect square? B squared is a perfect square, right? Because technically it has a coefficient of 1, and 1 is a perfect square. 1 squared equals 1. So we can take the square root of both of those. The square root of 1b squared is just b. The square root of 1 is 1. Okay, you'll put the same terms on the second factor. Again, just changing your plus to a minus. If you wanted to, you could even work through that foiling and you would get b squared minus 1, just to confirm that that's correct. All right, one more. So again, we have to make sure that this is a difference of square problems. Is that a perfect square? Yeah, right, 5 squared equals 25. Is that a perfect square? Yeah, 6 squared equals 36. And the other thing you have to remember, difference of perfect squares, there has to be a minus sign between those, which there is. So we can go ahead and use our formula. Our formula says you must take the square root of each term. So the square root of 25c squared is 5c. The square root of 36 is 6. We use those same terms, but with a minus sign. Okay. I know this seems kind of weird and different when you first do it, but after you do it a few times, it gets pretty easy, because again, it's just the same as everything else. It's just very, very repetitive. You're using that same process over and over and over again. Okay. When you do these problems, I am pretty sure that they will all be difference of squares. I don't think they're going to throw any tricks or anything in there for you. So square root of the first term, square root of the second term, positive, negative, or plus minus. Okay. If you need any help, please let me know.